Hello everyone, my name is Zero. Today I'm going to show you how binary works and the four basic operations. So that is adding, subtracting, multiplying and dividing. If you don't know why you would need binary and you haven't figured it out yet, well, it's useful for it's essential for everything computer science related. So everything computer hardware and digital electronics in general. Computers work with binary because they can't just simply calculate with decimal numbers like we humans can. And so yeah, that is why it's useful and essential that you know how binary works if you wanna build giant Redstone contraptions like computers and so on. The first step to understanding binary is to first understand number systems in general. Why don't we take a look at the most used one, decimals? So decimals got a range from 0 to 9, that is in total 10 numbers, and it basically works like that. Here we have our example 9178, and 9178 you can kind of split up in 9170 and 8. Now we can also convert that in 8 times 10 to the power of 0. 10 any number to the power of 0 equals 1, so 1 times 8 equals 8. Then 7 times 10 to the power of 1, 7 times 10 equals 70, and so on. And that goes for all the digits. So the very first digit, 0, and then 1, 2, 3, up to infinity. Now let's try doing the same thing with the base 2 instead of 10. So now with base 10, we only got two possible combinations, that is 1 or 0. Here we have 5 digits, or how you call them in binary, bits. These bits can only have 1 and 0, like mentioned before. Now let's take a look at the number themselves. So let's start at the bottom. Here we have the 1. You also read it from right, like right is the least significant, left is the most significant, like in decimal. And here we have 1 times 2 to the power of 0. 2 to the power of 0 is 1, so 1 times 1 equals 1. Here we have 0, because here we've got a 0, so that is 0 times 2 to the power of 1, so that is 0. Here, same, 0. Then here, it's getting interesting again, with 1 times 2 to the power of 3. So 2 to the power of 3, that is 8. 8 times 1 is still 8. Then we add 8 plus the one before, that is 9. Now our last number, 1 times 2 to the power of 4. 2 to the power of 4 is 16. 16 times 1 equals 16. 16 plus 9 equals 25. So now we know this number is 25 in decimal. Now if you take the levers and put some redstone lamps on top and write down on signs all the powers of 2 till whatever bit amount you want, then you can easily create numbers. Let's say we want the number 15. Then let's just go over here. 16 is so big. Then 8. 8 plus 4 is 12. Plus 2 is 14. Plus 1 is 15. That is 15 in binary. Now we want 50. So that is 32. 32 plus 16 is 48. 8 is too big. 4 is too big. And then 2. That is 50. Now another thing is you can easily calculate all the combinations of the numbers possible. So here we have 8 bits, and that is exactly 2 to the power of 8 is 256, and it's exactly how many combinations there are possible with 8 bits. So the biggest number is with all of them combined. So that is 128 plus 64 is 192 plus 32 and so on, and so on, and that equals 255. Now, with by adding the 1, we got exactly 256 combinations. Another thing that might be pretty useful to know is that each bit always stays on or stays off for exactly the amount of times it's in the power. So, for example, let's count up 1, 2, 3, 4, 5, 6, 7, 8, and so on. And you might have noticed each time we added 1, I always flick the 1 leader. Each second time I add I flick the 2 lever, and so on. So it always stays on for 1, turns off for 1, stays on for 2, turns off after 2, stays on for 4, turns off after 4, and so on and so on. So I hope you now understand binary, and I'll go on and now show you how to add binary numbers. Now here we have our two numbers we want to add. Here we have 16 plus 8 plus 1, that is 25. Here we have 1 plus 4, that is 5. So let's add those numbers. Let's start with the first bit, all the way on the right. Here we just add those two digits like we would do in decimal. So 1 plus 1, in decimal that would be 2. But here there's already an overflow, because we can't just write down 2 in binary, of course. So we write down a 0. And we have a so-called carry now. So here's a carry going over here. Now we're adding 0 plus 0. That is 0. Adding the 1 from before. And then here we've got a 0. Then 1 plus 0 is 1. Same for the next two. And we're done with this calculation. So now for subtraction. This is as well like addition, pretty similar or exactly the same to decimal. So here we have our two numbers. And now let's take a look at the first digits again. So we can get that 0 on the top one. We have to add 1 to this number. So that is a 1. Then we have a carry again. 1 plus 1 equals 10. So at the least significant digit bit we've got a 0. So we have to add a 1 again. And we also got a carry again. Now this carry goes over here and adds with this invisible 0. And then we finally have the one we wanted. So we have two 1s over here. And we can write down a 0, because we don't have to add any numbers to make those equal. Then here we have two 0s again, no carry from over here, so it's just a 1. So now we subtracted the number we got from the addition before, that was 30, minus 3, 1 plus 2, and get the result 27. 16 plus 8, 24, and plus 2, 26, and 27. Pretty easy. So now we're finally going to do something more complicated. Multiplying. That is exactly like in decimal, just way easier. The only multiplying you really have to do is times 1 or times 0. I think everyone in first grade could do that. So let's start. 1 times this number equals the number again. So that is 1, 1, 1, 1, and 0. The number we're multiplying are 30 times 5. Then the next one would be 0. I'm going to just mark a 0 over here, so we remember that to do the extra shift. Then we've got a 1 at the end again. So we just have to write the number here again, but just 1 to the right each step like in decimal. So, oh, whoops. We just have to write those 4 1s. And then we're done with our results, and now we just have to add those two, and we've got our final product. So 0 plus 0 equals 0, 1 plus 0 equals 1, 1 plus 0 equals 1, 1 plus 1 equals 0 with a carry. So now 1 plus 1 equals 0 as well with a carry, and we have to take account the carry from before, so it is 1 again. Then the carry from over here comes over here and also creates a carry, and creates a carry over here, and finally takes rest over here. And that is our final number. 2 plus 4 equals 6 times 16 plus 16 equals 22. 22 plus 128 equals 150, our right result. Now to our very last operation, division. This is also quite easy, as it can as we don't have to check how many times the number we're dividing through is in a number. It can only be once or 0 times. Okay, so let's align it. 1 doesn't go into 2, but works with 4. So I'm just going to mark that over here. And it works exactly 1 time. Surprise. So we're gonna write a 1 over here. Then 1 times 3, and then 4 minus 3 equals 1. Then the next digit comes down, that is 3, that goes exactly 1 time. One times 3 equals 3. 3 minus 3 equals 0. Then the next digit, 0. So now the number is too big, because 1 times 3 is doesn't subtract with 0, would be a negative number. So we're gonna skip it and write a 0. And bring down the next digit. That is a 1. Now 1, it also doesn't work, so we have to write another 0. Then the next number is 1. Now it works again. So 1 times 3 minus, and then equals 3. 3 minus 3 equals 0. So no negative number. So we write down a 1 and divide over here. So 3 minus 3 equals 3. Now the last digit comes down, that is a 0. It goes exactly 0 times. So we write the 0 over here. And now we've reached the end of our number, and that is our rest, 0. So the division was successful, yay! And our result is the number we multiplied with 4, that was 150, divided by 3 is 2 plus 16 plus 32. So that is exactly 50. Right result. Yay.